The second method that can be used is the method of sections. In this method, it is assumed that if the entire truss is held in equilibrium, then any segment of the truss is also in equilibrium. An imaginary line can be drawn to cut members of a truss in two to create a section, exposing each internal force as external in the free body diagram. The equations of equilibrium can then be applied to determine the member forces at the divided section. Three independent equilibrium equations can be used: the sum of the forces in the x equal to 0, sum of the forces in the y equal to 0, and the sum of the moments about a point in a certain direction equal to 0. First, we can determine the values of the reaction forces. This is shown on the screen. Next, we can look at the first section. This looks at the forces about joint A. Both of these values are found to be in compression, and therefore the second free body diagram with the correct sense is shown at the bottom of the screen. The next section shows the forces about joint H. The second free body diagram is shown to the right of the screen. The third section draws an imaginary line between F and G and C and D, and also cuts through C and F. The first free body diagram is shown to the top of the screen, and the second to the bottom. This third section looks at the forces about joint E. The second free body diagram is shown to the bottom of the screen. This next section draws an imaginary line between F and G and C and D, and it also cuts through C and F. This next section cuts through G and H, and B and C, and also through C and H. The next section draws an imaginary line between E and F, D and F, and C and D. The last section draws an imaginary line between G and H, C and G, C and F, and C and D. This gives the value of CG to be 0. Thank you for listening to our presentation.
Created using Powtoon.